Hello students, welcome back. So in this session, I'm going to be talking about descriptive statistics. I'm going to be talking about mean, median, minimum, maximum, mode, standard deviation, variance, percentile, and other things. So the first thing you do is import your NumPy as NP. All right, let's run this cell and there you go. Then let's say we have a data, okay, and this is our data right here. Array. Okay, this is my data 12, 15, 14, and so on and so forth. And this could be any number. This could be, let's say, monthly sales of monthly sales data in 1000s, or this could be age of somebody, or this could be temperature at any city, or this could be any data. And I print my array right here. And then let's calculate some statistics. Let's say I want to calculate mean value. So I'm invoking NumPy's inbuilt method mean, and I'm passing my argument. Okay, my argument is array right here. So this is my argument I'm passing, and I'm printing my mean values. Likewise, I'm calculating median. So there's an inbuilt method called median, and you pass your array right there. Likewise, if you want to calculate the minimum value, okay, it calculates the minimum value of the array, and I print my minimum value. If I want to calculate the argument minimum tells you the index, okay, the location of that minimum value. So let's run this and let's come over here. So let me explain you a few of these values. What do they mean? This is my array, this is my data, right? This is my mean value. So if you take all these numbers and you add them together and you divide by the total count, okay, this is the answer you're going to get, 18.7. Median, this is your median. Median basically tells you the middle number. So it's going to arrange all this thing in an increasing order, and then it's going to find the medium number or the middle number. That's your medium. Then you have minimum. In this case, the minimum number is 10 right there. That's your 10. Arg minimum right here. This arg minimum is this one. Arg minimum refers to the argument of your minimum. Okay, basically it refers to the index. So this is index 0, index 1, index 2, index 3, index 4. So 10 is my minimum, and the index of 10 is 4. And so it prints out 4 over here. Maximum. The maximum in this case is 35. And if you look over here, there it is. 35 is the largest number. Same thing, arg maximum. Arg maximum, okay, it actually finds the index where the maximum number is located, which is this one. So let's count it. 0, 1, 2, 3, 4, 5, 6, 7. And this is the 7th index. Remember, it always starts with 0. Okay, so it prints out 7. If you want to find the 25th percentile, there's the np.percentile method. And you just pass your array and you specify which percentile you want. If you want 25th, so write 25 over there. If you want 75, put 75. And that gives you 25th percentile, and this gives me 75th percentile. I'm assuming that you know the meaning of this median, mean, percentile, and this is not the same as percentage, by the way. This is called percentile. Okay, now let's say you want to calculate the mode. Now NumPy directly do not have an inbuilt method to calculate your mode. But what you can do, you can actually compute it using a combination of NumPy functions. So you can take this bunch of NumPy functions, two of them, okay, and you can find the mode of that. So this is my data right here, and we are trying to find the mode. Mode basically refers to the most common value occurring. So first you call np.unique method, okay, and data comma return counts equal to true. What it's going to do is going to find the unique for each one of them, and it's going to give you the count. So it returns a tuple. This is the value, okay, and this is the count for each one of them. All right, and then the way I find my mode, I say values np.arg maximum. Okay, arg maximum counts. So whichever you count, remember this is going to be an array. Okay, so I'm finding the index of the maximum number, and then I'm printing that corresponding value, and that gives me a mode. This arg maximum basically is exactly same as this one right here, arg maximum. Okay, that's what that is doing. Now if you want, you can print out your values and count. So if I print my values and count, you will see what it prints. Actually, let me run this first so you can see. All right, so see, mode is 2. So in this case, my mode is 2 right here. So if you count, your number of 2's is highest. Okay, so what exactly this values and counts is? So let's print out values, okay, and then I print my count too. Print count. All right, counts. And if you run this, it's going to print your values and count. So 1 2 3 4 5 and 1 5 4 3 2. What basically is telling you that the number of ones is only one. Okay, values and count. Twos, how many twos are there? There are 5 twos. You can count 1 2 3 4. Oh, sorry. 1 2 3 4 and 5 twos. All right. How many threes are there? But it says 4. If you count the threes, 1 2 3 and 4, 4 threes. And same thing, how many fours are there? There are total 3 fours. How many fives? Twos. Clearly, in this case, the number of the count, okay, the count of 2 is higher because you have 5 twos. All right, and this is what's happening over here. It's basically finding this 5 and it's printing this corresponding number over there. Okay, now let's understand variance. So sometimes you have to calculate variance and standard deviation. So let's try to understand variance and standard deviation through a data with different type of variance. So let's say I have these numbers. Okay, data 1 is these numbers 5 5 5 5 5 5. Okay, clearly you can see there is no variance. Every number is same 5 5 5. There is no change. So in essence there is no variance. Let's look at another data right here. In this case you can see there is some variance. You see 4 3 5 6 7 3 5 6 4 5. Not a lot, but there is some variance. Now look at the data 3 1 1 0 0 5 9 9 10 10 5, right? This one has a lot more variance than this data, and this data has more variance than this. So this one has no variance, you can see that. This one has some variance, and this one actually has a large variance. All right, let's try to see if we can actually do a mathematical, or we can quantify this term called variance. Variance basically talks about how much your data is varying around the mean value. So there's an inbuilt method called .var, which is a short for variance, and you pass your data 1. Okay, I pass my this data 1. So that's going to give me my variance. And likewise, you can calculate standard deviation by using this inbuilt method standard STD. And then I print my data, and then I'm printing my variance for each one of them. So this is my variance data for data 1. This is my variance, okay, for data 2, and this is my variance for data 3. So I'm printing each one of them next to each other, and there you go. So this is my first data, and you can see the variance is 0. Okay, standard deviation, if you remember from your high school math, is basically under root of square root of variance, which is 0. Now look at this data right here. This has some variance, and you can see the number is 1.56. This is 0.0, this is 1.56, and the standard deviation is 1.2489. And look at this one. This one has a little bit more variance, and look at the number 16.4. So you can see the variance is going up. Okay, you see that? You see that? And that's because your data, okay, no variance, some variance, and a little bit more variance. All right, now application. So let's say you want to find relation between two variables. So let's say you are finding relation between two variables. Let's say your x1 is the number of hours some students they play games, video games, and these are their exam scores. So one student played video game only for 1 hour. His score was 90 out of 100. One student played only 2 hours. His score is 90, and so on and so forth. So the one student played for 3 hours. His score is 85. Then one student also played for 3 hours. His score is 80. One student played for 4 hours. His score is 80. One student, this is another student played for 4 hours. His score is 70. So, you have all these scores. So let's try to find, is there any relation between x1 and x2? In other words, are there any relation between the hours somebody spends playing video games, which is this right here, and exam scores, like how much they score in the exams? So there is an inbuilt method called COV, C-O-V, which calculates the covariance. And I'm also calculating my correlation coefficient. Correlation coefficient will always be between -1 to +1. -1 means that as one value goes down, or sorry, one value goes up, the other value goes down. So just to give you an idea, let's say if this is your data right here, right? And this is your x1, and this is your x2. So if x1 goes up, your x2 goes up too. If x1 increases, your x2 also increases. This would be +1. Okay. On the other hand, if your data x1 increases but your x2 goes down, Okay, so this would be -1. In other words, this is going to be negative and this is going to be positive. So let's see what is the relation. In this case, my relation is, you can see the answer coming out to be -0.89. Okay, -0.89. So that tells me it's closer to -1. So that tells me that as my x1, okay, as one of the variable is going down, as my x1 is going up, your x2 is going down. So as my x1 is increasing, okay, your x2 is decreasing. And this is the one. This is the representation of this one right here. Okay. All right. Then let's find correlation between more than two variables. Let's say we want to find correlation among four variables. So come down over here, copy and paste. So let's say I have x1, okay, I have x2, x3, x4. This could be any variable. This could be resistance with current equal to 2. This is voltage measured through a top quality voltmeter. This is a voltage measured through a poor quality voltmeter. And this is some other variable with a negative correlation. And we want to find if there's any relation between these four variables, among these four variables. So first thing you do is you stack them. Okay, you say np.array x1, x2, x3 in a list bracket, and then you call your covariance matrix on that. All right, and then you find your correlation coefficient. So for correlation coefficient, I'm using the inbuilt method corr coefficient. Now let's read some of these values. What do they mean? So let's read this value. This one. This is telling you, by the way, each one of them, this one is your x1, this one is your x2, this one is your x3, and this one is your x4. This column is your x1, this column is your x2, this one is x3, and this one is x4. So the way you read, like this one, this tells you relation between x2 and x1. Okay, so the correlation between x1 and x2 is 1. So in other words, if your x1 is over here, x2 is over here, so as your x1 is increasing, your x2 will also increase. That's what it's saying. Okay, that's what this thing is telling you. Let's look at this number right here. This one is a relation between x2, okay, and x3. So what is this saying? Now look at this value. It's almost closer to 0. So 0 means, by the way, this is relation between x2 and x3, right? So this is telling me that as your x2 is increasing, your x3 can be increasing, can be decreasing. So basically it could be going like this. Okay, this is how your value is going. Basically it's all over the place. So there is no pattern. It's not going up, it's not going down, it's basically going all over the place. All right, let's look at this value right here. What is this? This is minus 0.9. This is almost closer to -1. And this one tells you relation between x2 and x4, right? Because this is your x4, all right? This is your x4 and this is your x1. So this number, x2, okay, this is your x2 and this is your x4. So it's minus 0.9. That means it's almost -1. So it's telling me that as your x2 is increasing, your x4 is also decreasing. Okay, that's what this is telling me. All right.